This is question number 16, part A, and we are told figure 11 shows a setup that can be used to verify Charles' law. So we have a meter rule here that is inserted in a beaker with water. We have a stirrer inside the beaker. We have a rubber band tying the a capillary tube and the thermometer together. Then we have heat supplied. So our capillary tube has an index. So it means that the volume, the air inside the capillary tube is trapped by the index. So that is the setup. Roman number 1, explain how temperature is measured. So the temperature of air in the tube is measured by measuring the temperature of water around the capillary tube. Since you can see here, we have a stirrer there. So the stirrer is used to distribute equal distribution of heat in water. So to answer this question, you are supposed to say by measuring the temperature of water by measuring temperature of water, since temperature of air is equal to that of water. So that's how you answer that, and you'll be able to get 2 marks. So let's get to the next part of question number 16. Part 2 of question number 16, we say volume of air in the tube is measured. You are supposed to explain. If you go to back to the diagram, you can see that the cross-section area of the tube is uniform. So if we measure the rise of if we measure the length of air column, it is proportional to the volume. So to be able to answer this question, you would say by measuring the length of air column volume of air is proportional. Volume of air is proportional to the length since cross-section area is uniform. Area is uniform. Okay, part Roman number 2, state how pressure is kept constant during the experiment. So pressure is kept constant by keeping the tube vertical and open throughout the experiment. And that's how you answer that. You'll be able to get 3 marks in this area. So let's have a look at the next section of this question. So part 3 of this question, state how the measurement in Roman number 1 can be used to verify Charles' law. So Charles' law says that if the pressure is kept constant, the volume is directly proportional to temperature. That is, in case of rise in volume, rise in temperature, the volume will also rise proportionally. So the experiment can be used by one, obtain several values of volume that is V and temperature. So you get several of them. You get several of them. Number 2, plot a graph of volume. Plot a graph of volume against absolute temperature. The graph, if you draw the graph of volume against temperature, so it means that the volume, that's the temperature. You find that the values are increase in temperature increases the volume. So you can say a straight line through the origin is obtained showing that Charles' law is obeyed. So that is a change in volume. A change in temperature is proportional to change in volume. And that's how you answer that. Let's go to the next part of this question. So Roman number 4, state one precaution that must be taken to ensure that the temperature of air in there is accurately measured. As you see in the diagram, the temperature of air is accurately measured by stirring the water so that we keep a equal distribution of heat. So this can be answered: stirring water before taking the recording. Stirring of water before recording, taking the recording of temperature and volume. So that's how you answer that. So let's see the next part of this question. Part B of question number 16, we are told a fixed mass of gas initially at 20 degrees centigrade is heated at a constant pressure until its volume doubles. Determine its final temperature. So according to the Charles law, we can say if we take the first reading and the second reading, that is V1 over T1 is equals to the ratio of T to V2 of and T2. And in this case, we are told that the volume is double. So meaning volume 2 is equals twice V1, because we are told the volume is doubled. And therefore we can say that is, we can say V1 over T1 is equals to, now V2 is the same as 2V1, 2V1 over T2. We can make T2 the subject, so we cross multiply. So we say T2 is equals to, T2 will come here, so we multiply, that is 2V1 T1 divided by V1 comes here, V1. So this V1 can cancel like that, and we will be left with T2 is equals to 2 T1, which is equals to 2, the T1 is 20, so we say it is 20 plus 273, that is 273, which you get, this is 3, which you get, it is equals to 586. So 586, you subtract the absolute temperature 273, and that will give you 313 degrees centigrade. So that will be the new temperature when the volume doubles from 20 degrees. It doubles. So that is how we work out that question.